Hi everybody, welcome to another video in Math 1324, section 7.4, permutation and combination. Before we go to actual permutation and combination, we need to learn about factorial first. So factorial are natural numbers. Actually, it works for the whole number as well. So we define factorial of a number. The notation is the number, then exclamation point. It is the product from that number minus 1 times that number minus 1 times that minus 2 until you hit 1. We define 0 factorial equal to 1. Right. Now, so for example, we have 5 factorial that equal to 5 times 4 times 3 times 2 and times 1. So that actually is a sample. So whatever the factorial is, we start from that number, subtract 1, the product of all of that number counting backward to 1, and that gives us 2 times 3, 6, 4, 24, 120. So 20 times 6, 120. Right. Now one nice thing about this factorial, the reason that we write this notation is very versatile. We can say 3 times 2 times 1 is 3 factorial, right? So we can essentially say 5 factorial is 5 times 4 and then 3. If you want to stop and you don't want to write any further, we can just say, okay, we stop there. Now, let's try that again. 5 factorial. If you stay from 5 to 4, and if you decide you don't want to write any further, yeah, just put the exclamation point there. So factorial from 4, factorial of 4 is 4, 3, 2, and 1, and then the 5. So we just write start from that number, going back, and then if we decide to stop, we put exclamation point, the factorial, meaning that we will start from that number again on the way to 1. So for example, 7 factorial. Of course, 7 factorial is 7 times 6 times 5 times 4, 3, 2, 1, right? But if we want to, we can just stop wherever we want. I just decide to stop at 5. Why is that? Well, because we already have 5 factorial is 120, right? Yeah, so we just stop where we want. And then we just put a factorial. We understood that it will go back to 1. Some 120. So 7 times 6 times 120, and we have 50, 40. Right. So that. Next, to evaluate 10 factorial over 8 factorial, we have 10 factorial is 10 times 9 times 8 times 7, 6, counting back to 1, right? But I said I can decide to stop at any number I want to. So if I just stop at 8, I just have factorial. Because from here will be 8, 7, 6, 5, 4, 3, 2, 1. So I write like that. So we just have cancel it. And we have just 10 times 9, which is 90. Right. So pretty much that. Now the application for this factorial is to arrange n object in n position. There are n factorial ways. For example, let's say there's in the actually hit the light. Let's say in a race of 5 people, and there are 5 different finishing order. Alright, so let's do like we did on the previous section. The first place finish, second, third, fourth, and fifth. Right, so the first person to different order, there are 5 people, so there are 5 ways to select, 5 ways for the person to finish first, any one of those 5. and after that one is finished, we have 4 left, and out of those 4, one of those 4 we finish second, and then we have 3 left. 3 of those can finish third, and then 2 left. 2 of those can finish fourth, and then 1, and multiply all of this. In this we have 5 factorial, which is 120 different orders. Okay. So the orders here is very important. So in permutation, the order is very important. But now the difference of what we just did and what we have here, the permutation, we don't have to choose all 5 of them. Let's say we still have 5 people in a race, but we only interested in the first 3 order, the first 3 finished. So in that case, this is called the permutation of an object and taking R at a time. So in this case, if we're interested in the top 3 finish, we will take 3 at a time. Select 5. We can write the notation as NPR or P of NR, or is this. The formula is n factorial over n minus r factorial. Right. Let's just jump to one example, and then we'll see how that works. Right. Here's some example. A club has 10 members. How many different ways to select a president, vice president, and a treasurer out of 10 members? Of course, a person cannot hold more than 1 role. We should have that too. Right. Now let's just say we don't have the permutation yet. We just use the slot for the president, the vice president, and the treasurer. Right. There are 10 people. You can select any of those 10 to be a president, and after that there are 9 left, and one of those 9 will be vice president. So there's 9 options, and after those 2 are taken, there's 8 left. One of those 8 will be treasurer. So we multiply all of this, and that gives us 720 different ways. How many different ways? So that the answer is 720 different ways to select this. Right. Now, but in terms of permutation, so if we use permutation, this is what we write. So order, since the position are important, so the rows are different. That means order matters. Does matter. So that means we have permutation. If order does not matter, or if the rows are the same, that will be the next part is combination. But here order does matter, that permutation. And we have the permutation. We select 3 rows. Permutation of 3 out of 10 people. So that it means 10 and 3. So the formula for permutation, n factorial over n minus r factorial. 10 factorial over 10 minus 3 factorial. So that's 7. So that gives us, for this we say 10 times 9 times 8, and we stop at 7 because we do have the 7 at the bottom. That cancel out. And we have 10 times 9 times 8, that's 720. Right. So either we use permutation or we just use the slot like this. Right. And next question, how many ways to award medals to a race of 8 people? So there will be 3 different positions here, or 3 different roles here. So we have gold, silver, and bronze. So the 8, 1 out of 8. To select gold, to award gold, there are 8 people, so one of them can win 1 out of 8, so it's 8. And then that person is taken. Now there's 7 left to be awarded silver, so one of them will win the silver. And after those 2, there's 6 left to choose the bronze. 8 times 7 times 6. 36. Right. Now if we use, once again, rows are different, order matters, permutation. So, because each one of these have different rows. Order matters. Permutation. And of course this is, we have 3, so permutation of 3 out of 8. So actually if we use the calculator, we can use hit math and then go to probability. That is the permutation option 2. But of course we're not going to enter like that. We have to enter the number first, 8, and then math, probability, permutation. So I hit the combination. Let's do that again. Probability, permutation, 3. So we choose 8, 2 from 8, taken 3 out of 8. 36. Right. So whether you do it by hand or using the calculator is fine. Right. Next. How many different ways to arrange 6 boys and 6 girls in a line if the boys and the girls are alternating? Right. So this is a bit more difficult. So let's say if you have the position, you have just say girl boy alternating. One, 2, 3, 4, 5, 6. Or the boy go first. Right, so there are 2 different settings here, right? And for each one of them, you're going to put 6 boys into 6 places, and then put 6 girls into 6 places. Again, if you put 6 into 6, 6 into 6, so that means you have P of 6, have 6 to arrange 6 boys in 6 positions, and arrange 6 girls in 6 positions. So multiply them, because whatever you choose for the boys does not affect whatever you choose for the girls. So for each time you select the boys, you can scramble those 6 girls into the position. So that's why you like 2 different operation in the whole, 2 different tasks in the whole operation, or 2 different states. So put in the boys in place first, and then you put in the girls in place. The multiplication rule say you multiply those together. Right. So that is, we have that. Now, or if we have this arrangement, we put the boys first, and then we choose the girls. So, and then what we do is we're just going to add this together. of course 6 and 6, or that like if you arrange 6 people in 6 places, that's 6 factorial. Or we can use permutation of 6 of 6, which is 720, or 6 factorial. By the way, factorial is option number 4. So we have pretty much 6 factorial times 6 factorial, and then we just add them. So 720, 6 factorial times 720, and then plus 720 times 720. And we have that. Right. So whatever we choose for one, the boys, and then we choose the girl, and then we multiply together, and then there are 2 different arrangements. So I just add them. Right. Next, how many different ways can 5 people A, B, C, D, E sit in a row at a concert if A and B must sit together? Right. So A and B must sit together. So A and B pretty much is as a unit together. So we have AB together, and then we have C, D, and E. So pretty much you have 4 units here, 4 units, and then you rotate, interchange. So we have 4 units in 4 positions, and order does matter. So because we can rearrange them, but all 4 units. So that gives us 4 positions, and then put 4 people into it. If we use the formula, n factorial over n minus r factorial, 4 factorial over 0 factorial. By definition, 0 factorial is 1. That gives us 4 factorial, which is 4 times 3 times 2 times 1, 24. Right, but that's not it. A and B as a unit, but A can sit on the right, B is on the left, or A is on the left, B on the right. So there's 2 between A and B together. There's 1. There are 2 different orientation. Could be AB, could be BA. So whatever number here, when we choose, after we put all those 4 units into place, and then A and B can decide. That's second stage. You choose A or B, or B then A, or A then B. So that means 2 ways to arrange 2 people into 2 seats. So 24 times 2 is 48. So that's 48 different ways to select, to rearrange these 5 people. Right. Now we go to completely different things. It's called a combination. Combination. A combination of n object taken R at a time where order is not important. So order is not important. The formula is this. So, of course, the difference between the combination and permutation is just order does not matter. So, let's look at the first example and see what is the difference here. By the way, when we see the order does not matter, whatever you do not put them in the slot like this. Because when you put in slot like this, that means order is important already. So we cannot do that. When it is order does not matter, don't put the slots. Right. A club has 10 members. How many different ways to select the committee of 3? So now you see a difference here, right? This is a committee of 3. So the roles in the committees are interchangeable. So that's why we write roles are the same that means order does not matter. Orders do not matter, or not as important, not important. So that means this is a combination. So, and we select committee of 3, so select 3 out of 10, and we have 10 factorial over 3 factorial over 10 minus 3 factorial. Right, so 10 factorial, 3 factorial, I'm just going to leave it like that, and 7. 10 minus 3, 7. Now 10, I can say 10, 9, 8, and I stop at 7 factorial. 3 factorial is going to be 6. 3 factorial is 6. And 7 factorial, I'm just going to leave it like that because it does cancel nicely. And so we have 10, 9, 8 divided by 6. 10 times 9 times 8, that's 720. Divided by 6, that's 120. Right. Or if we have a calculator, we say 10 math combination of 3 out of 10 is 110, right? So I should be able to use both the formula and the calculator. Right, next. A certain state lottery consists of selecting 6 numbers from the set of 54. Actually, this is the state of Texas. How many possible different tickets are there? Well, so say just select a number. When we select a number, we just bubble it, and the order of selecting the number does not matter. So in that case, once again, order does not matter. So that is the combination. And the combination of 6 out of 54. So we have C, 54, and 6. This I think we need a calculator because even though we do it by hand, we still have, let's see, that's still complicated. 6 factorial, 54 minus 6 factorial, right? And that involves very big number, so calculator should help. So we have 54 math combination of 6. So we have that 5, 8, 2, 7, 1, 6, 5. 25 million and 27, 165. Different combination. Right, next. A basketball team has 15 players. How many different ways to select a starting lineup of 5 players, assuming no position requirement? So let's, of course, in the basketball team, usually there's different person for different roles, play different roles or different position. So let's assume that we don't have that. We just put 5 on the row, like so in that case we have no position. So in that case order doesn't matter. You just put 5 on the field. Doesn't matter which, how or we select them. So again, position not important. Order does not matter. So when roles or position are not important or do not matter, that where we have a combination or orders does not matter. that is combination. And combination of 10 of 5 out of 15. Right. So that C 15 and 5. Of course we can use a calculator, but I just demonstrate what if we don't have a calculator. Right. Will be n factorial over r factorial over n minus r factorial. So 15 over 5 and 10. Right. Now 15 factorial I can write as 15, 14, 13, 12, 11 and 10. We stop at 10 because we do see 10 factorial at the bottom. What at the bottom? 5 factorial here. We still need to write it down. Of course that's 120, but I'm just going to say it 5 times 4 times 3 times 2 times 1. Right. So let's try to simplify as much as we can. 10 and 10. That's easy. Alright, we have this. We can say 4 and 3 are 12. That cancel out. We say cancel out 15 is 5 times 3. Right. So that's gone. Next we have 4 and 2 at the bottom. The 4 and the 3 cancel out. We have 3 left. And the 2 and the 14 cancel out. We have 7. So pretty much we have what? 7 times 13 times 3 times 11. So that's what we have. So 7 times 13 times 3 times 11. And that's 3,300. 3,003. Let's say if we use a calculator. And we have the combination of 5. Of course we have the same thing. So that's how we do it. Right, next, how many different ways to select a group of 4 people to send to space out of 10 Americans and 12 Europeans. Right, so we have the group of 4. So we put 4 people in the space. Right, once again, we don't assume we don't have any roles. Even though when we select a role, a group to send into space, usually we have roles like we want to send 1 engineering, maybe 1 doctor, maybe a lab scientist, something like that. So different people with different roles, so can do different things. But let's assume that we don't have any of that. It did not say anything. Let's say the spaceship is well equipped. You can just put anybody up there. Right? So group of 4 people to be, and then send out 10 and 12. It did not say how many of American, how many of European we have to do. So in that case, they just select excuse me, select 4 people out of 10 and 12, so that out of 22. So pretty much there's no, we select that, order does not matter. So that means we have combination of 4 out of 22. So that means combination of 4 out of 22. 22. Combination of 4. So that gives us 7,315. Right, next. How many different ways to select 4 people with 2 Americans to be sent to space that are from 10 Americans and 12 European. So there are 4 people, but 2 Americans. So that means in this group we have 4 people. We have 2 Americans. We choose 2 American first, and then we choose 2 European. Now, we can choose 2 American out of 10. And then we choose 2 European also out of 12. Because there are 10 Americans and 12 Europeans. Now this is just like the 2-stage problem. We select all the American first, and then we choose 2 European. Whatever we choose here doesn't affect whatever we choose there. So we just multiply one to another. So we said to choose 2 American, again order does not matter. So we choose 2 out of 10. And then for European we choose 2 out of 12. So pretty much that. And we compute both. Right, so T of 10, 12. I'm just going to use a calculator here because this is simple enough. Of course, we have to specify that number at 45. Actually, I'm just going to do that by hand. 10 factorial over 2 factorial times 10 minus 2 factorial. And then we have 12 factorial over 2 factorial, 12 minus 2 factorial. Yeah, just formula. Right, so we have 10 factorial. Actually, we're just gonna, and then 2, 10 minus 2 is 8, 12, 2 factorial, 10 factorial. Right, and then you can just calculate each one of them. But since we multiply, we just go ahead and cross out this out. That's nice. So we have 12 factorial would be 12, 11, 10, 9, 8 factorial over 2 factorial is 2, 8 factorial is 8 factorial, and then 2 factorial again is 2. So cross out the 8 factorial. 2 times 2 is 4. Cancel with 12, so it's going to be 3. So we have 3 times 11 times 10 times 9. We have 2970. Right. Or if we do using the calculator, we have combination of 2 out of 10 times combination of 2 out of 12 okay, that's what we have. So we can do it by hand or we use a calculator, but more importantly we need to determine which one is the combination, which one is the permutation. So when order does matter, we talk about the position or we talk about different rows, that permutation. About combination, we talk about people in a committee, in a group or something. So that why the order doesn't really matter in a group or in a committee. So in that case, that's the combination. And of course the formula for combination and the formula for permutation. Right. So with that, we end section 7.4 here. As always, thank you for watching and see you in another video in Math 1324.